Okay, so this is an extra video that I'm making because I'm worried that some students struggle to understand these concepts. So I'm going to go over it in a little bit more detail with some more specific examples. So this is actually the assignment that I've given to my students. And I'm going to go through and show each type on the assignment, but with different numbers so that you can still do your assignment. So for example, I'm just going to go through each of these and change my angle measures so that you can get the idea without me giving you all the answers. Okay, so right here, I'm using my central angle and inscribed angle theorems to kind of figure this out. So the first number one thing I need you to be aware of is that this arc right here is the same thing as your central angle. Your central angle and your arc are the same. Your central angle is an angle that literally goes through the center. If it doesn't go through the center, it's not a central angle. And circumscribed angles we're not even worrying about in these problems. Those are angles that are outside your circle, and we don't have any angles outside our circle in these problems. So those are the ones where the two angles will add up to 180. We're forgetting about that for now because we don't have any of those in these specific problems. We're only looking at central and inscribed angle theorem. So the only thing we need to know for these problems is that the central angle or the arc is double the inscribed angle, is twice the inscribed angle. So like right here, x is my inscribed angle and 114 is my arc or central angle. So if I want to find x, well, it's going to be half of 114. So half of 114 is 57 degrees. So x is equal to 57 degrees. Number 7, my inscribed angle is 32. I know that my central angle or my arc is double the inscribed angle. So 32 doubled, x is equal to 64. And then number 8, this is 36 degrees, is my arc or my central angle. So my inscribed angle is half of that. Half of 36 is 18 degrees. So my y is 18 degrees. And then this right here is a right angle, which is 90 degrees. And my arc is double the inscribed angle, so double 90, x is equal to 180 degrees. So the only concept you're using on these problems is that the central angle is twice the inscribed angle. So I want you to go ahead and pause the video and try those 3 problems on your assignment. Okay, so once everybody's had a chance to do that, we're going to go on to this problem, and I think this one has been a little bit overwhelming for people, so hopefully I can make it a little less overwhelming. So I'm going to, again, change these angle measures. So we're going to say XZ is 70 degrees, VYZ is 30 degrees, and it tells me that YZ is a diameter. Now that's an important piece of information because if this is a diameter, then that means that this whole arc right here is half the circle. So this is 180 degrees. And this whole arc right here is another half of the circle. So that whole arc is 180 degrees. So just by saying YZ is a diameter, that gives me quite a bit of information. And then arc XZ, so this arc right here is 70 degrees. And then angle VYZ, so I've got to go in that order. VYZ, so this is my angle VYZ, is 30 degrees. And then it gives me tons of different angles it wants me to find. So I'm just going to start with one and kind of go from there. So the first is XYW. So I have XYW is this angle right here. And that's an inscribed angle from these 2 points. And inscribed angles, just like we talked about on the previous 3 problems, are half the arc. So if this is 70 degrees, then this is 35 degrees. So this here is 35 degrees. And then number 10 is angle XWZ. So XWZ, well, that's just the same as my arc. My arc and my central angle are the same. So if that's 70 degrees, this is 70 degrees. So I have 70 degrees here. And then I have angle XWY. So XWY is this angle. Well, the central angle, that would be the same as my arc, but that's just the arc from X to Y. So I know the arc from X to Z is 70, and I know the whole arc is 180. So just to find this piece of the arc, I can do 180 minus 70, which is 110 degrees, which means the central angle is 110 degrees. So here I have 110 degrees. And then number 12, I have YVZ. Well, that is right under this whole arc. That's this angle right here, YVZ. And so if my whole central arc is 180, this is half of 180 because it's the inscribed angle. So this would be 90. Arc XYZ. So if I go in that order, X, Y, Z. So that's the entire circle besides this portion right here. Well, a whole circle is 360 degrees. If I subtract this 70, then I'm down to 290 degrees. And then 14 is the measure of arc VZ. So if I look here at VZ, well, I'm not sure what that arc is. And honestly, this is what I do and what I would have you do when something like that happens. If you don't know what one is, skip it and come back to it because you might get enough information later that you'll be able to answer that question a little bit better. So I'm going to just go ahead and go on and look at arc V, so wait, that's the one I'm skipping. So I'm going to look at arc XY. Well, arc XY, we actually already found that earlier because it's the same as this central angle. So arc XY is 110 degrees. And then angle VZY. So I'm going to look at VZY. Sorry about that glitch in the video. I have a cold and I was coughing. But while I was coughing, I realized the way to do this problem right here. So arc VZ, that's this arc right here. So if we look here, this angle is coming from those 2 points, and it's 30 degrees. This inscribed angle is 30 degrees. So its arc is going to be double that angle, which is 60 degrees. So this is 60 degrees, which it's a good thing we found that because that's going to help us find angle VZY. So if I look at angle VZY, that's this angle right here. And that's going to be half of this arc, but I'm not sure what this arc is yet, but I can find it because this arc is 60 and the whole arc is 180. So 180 minus 60 is 120 degrees. So VZY must be half that, which is 60 degrees. And then the next one asks me for measure VY of arc VY. Well, I just found that, so that's 120 degrees. And then it asks for angle WXY. So WXY is this angle right here. And this one, at least the first thing that comes to my head to find this, is not even from this unit. But if you look right here, there's the triangle. And I know triangles add up to 180, and I know the other two angles. So if I do 180 minus 110 minus 35, well then this angle also has to be 35 degrees. So this is 35 degrees. So I know that's kind of a lot of information at once, so I would recommend just leaving this up on the screen, but pausing the video and having you try this very thing on your homework assignment. Okay, so hopefully you've tried numbers 9 through 18 on your homework. I think that these last few should be much easier. So 25, 26, and 27 are in your guided note packet. All of these theorems are defined, so you can get them right from there. Numbers 19, 20, and 21, we did problems just like those in your note packet, so you can look back at your note packet for those. And 22, 23, and 24, these are those circumscribed angle ones. So let's say that this angle is 110 degrees. Well, this is 90, this is 90, so these two have to add to 180. So to find my question mark angle, I do 180 minus 110 is equal to 70 degrees. So my question mark angle is 70 degrees. And that's the exact same way I do 23 and 24 as well. So hopefully, those of you who were confused after yesterday's lecture, that this kind of helped to clarify some things a little bit. It's definitely just going to take some practice. If you're watching this in class on Friday with my sub, then I now just ask you to work on this assignment, get it all finished, and you're going to correct it at the end of the hour. So just do the best you can, make sure that you're working and that you're being respectful, and the sub will have you correct it during the last 5 minutes of class.